Okay, this is page 3 and 4 of the Unit 2 review. Number 15, for each of the following, list the transformation and give the vertex and axis of symmetry. Okay, so transformations, looking at the first one. Remember, you need to look at this as pieces. So this piece right here, okay, means a vertical compression. By a factor of 1/2. Okay, and we have the next one. We're going to look at this piece right here. It's inside the absolute value, and this is +2 because of insider's lie. We're going to move left 2. And then we have this -6 on the outside, and that -6 we know means down 6. Okay, so the vertex, we know the vertex, this is the x piece because I'm moving left 2, but remember, if we're moving left 2, that means it's -2. And then the -6 we know was down, so our y coordinate for the vertex is -6. And the axis of symmetry, so axis of symmetry is going to be the line that cuts that absolute value in half, so it's the same on both sides. You know what that word symmetry means. And then the axis of symmetry is just going to be x equals whatever your x value of the vertex is. So x equals -2, because it is a line. We're looking for the equation of a line. That's what the axis of symmetry is. Okay, let's go on to the next one. Remember, again, we're looking at the pieces, and we're referring back to this. Okay, we're referring back to this. Every time we were talking about transformations, we're looking at this formula right here. Okay, if you don't remember the formula, you might want to add that to the top of this page. Okay, so we have minus in front. Okay, that's separate than this 2. Okay, and then we have what's on the inside here. And then we have +5. Okay, so the negative means I'm going to reflect over the x-axis. That 2 means a vertical stretch. Okay, and then the -2 on the inside. Remember, insiders lie, so that is actually going to be moving to the right 2. So shift to the right 2. And then finally, change the color of this. Let's make this guy orange. +5 on the outside means shift up 5. So my vertex is going to be at 2, 5. My axis of symmetry is going to be x equals 2. Okay. Go ahead and do the next one quickly. That negative in front we know means reflect over the x-axis. +4 means left 4, and then the +6 means up 6. Okay, so our vertex is at -4, 6. Axis of symmetry, x equals -4. All right, let's move on. Give the domain and range of the relations shown in the graph. Okay, remember, domain is from left to right. So we're starting over here and we're moving left. We know that because this comes to the edge of the graph, it's going to go on forever, which means that that graph is moving slowly out to the left. So that's going to be -infinity to +infinity. the range. So if I start down here and I'm moving up, notice the first value of the range isn't until right here. And remember, I want the y value, so that y value is at 1. I'm going to use a bracket because it does include the 1. And then if I keep going up, it goes to positive infinity. Okay, over here. All right, so this graph, start from the left-hand side and move over. Notice the first value for the domain is here at -3, and it does include -3. And then if we keep moving out, remember this is going to go on forever, so this is going to go to positive infinity. And then the range, starting down from -infinity to positive. Okay. Next, the function f inverse of x equals 2 over 5 times x minus 3 is the inverse of what function? Okay, well, what it's asking you is, what is the inverse of this function? Well, the inverse of this function is going to be the inverse of this inverse function, which is kind of confusing. So whenever you see inverse, you just need to switch x and y. So we're going to do y equals, I'm going to change this right here to y. Y equals 2 over 5x minus 3. I'm going to switch my x and y. X equals 2 over 5y minus 3. Now we're going to solve for y. Plus 3, plus 3. Move over here. X plus 3 equals 2 over 5y. Multiply times the reciprocal. So that's going to give me 5 over 2x. And remember, this is times this whole thing, so you need to distribute in here. Put that in the calculator. 5 divided by 2 times 3 is 7.5, or as a fraction, if you do math enter, it's 15 over 2. So plus 15 over 2 equals y. So the original function would have been f of x equals 5 over 2x plus 15 over 2. Okay. Okay, the next says all the following equations are the same except. The other word you might see here, it'll say which of the following equations are equivalent. That's the same question. The way that you can check to see if these are equivalent is if you solve for y. Once you solve for y, any of the equations that are the same are going to be equivalent. So I'm going to plus 4x. I'm solving for y. So the key here is to solve for y. And we don't have a lot of room here. Solve for y. So this one is y equals 4x plus 12. Okay. Here we're going to have to distribute. And then once we do that, we'll move the 3 over. So go ahead and solve all of these for y. Okay. So once you solve for y for each of these, I'm not going to go through this because you should know how to solve for y. Notice that this one is y equals 2/3 x minus 7. This one will reduce, or once you solve to y, be y equals 2/3 x minus 7. And then we see this one's y equals 2/3 x minus 7. And it says all of the following equations are the same except, so A is the one that is not the same because that one ended up being y equals 4x plus 12. So you've got to solve for y and then compare. This one says except, which means that B, C, and D are all equivalent equations. All right, let's move on. Find the inverse of the following. This is review from Unit 1. So remember that the trick is switch x and y and then solve for y. I'm going to pause the video because you should be able to do that yourself, and then I'll put the answers on here. Okay, starting with number 19, this was the algebra for this one is pretty straightforward. You should have got f inverse of x equals -1/3 x plus 4 over 3. For the next one here, a lot of you missed this question on the last test. The first thing you need to do after you switch x and y is you have to multiply times the 5 on both sides, okay, because you've got to get rid of that denominator as a 5. And then once you have the 5 over there, you just subtract 3, And then this one has 2 times y, so then I divide it by 2 on both sides, which left me f inverse of x equals 5 over 2x minus 3 over 2. And then the last one, it's pretty straightforward. Don't forget, when you have a fraction, you're going to multiply times the reciprocal. In this case, that fraction was negative, so I have to multiply times negative 3 over 2. And again, remember that you have to multiply times the whole expression on the left side if there's an expression over there, which is going to give me f inverse of x equals negative 3 over 2x plus 15 over 2. Okay, number 22. Find the graphical characteristics of the following function. We told you we were going to see this on every single test. So that function family, if we look over here, we see that this is a v, so that's absolute value. Parent equation is f of x equals the absolute value of x. The vertex, my vertex is right there, and I see that my vertex is at, I'm going to write it on here because it'll help with some of the other things we're going to do. So that's negative 3, 2. Oh, negative 3, negative 2. So negative 3, negative 2. Okay, the axis of symmetry, which we've talked about, is the line that it cuts that graph in half, and it's the same on both sides. So, and again, that's a line, so that's going to be x equals negative 3. The domain from left to right, remember this goes on forever, so it's negative infinity to positive infinity. The range, this graph is pointed down, so the range is at negative infinity. But notice the last point is right here, and we're talking about the range, so we're talking about the y value. So it goes to negative 2, and it includes negative 2, so you're going to use a bracket. Minimum or maximum, we see right here at our vertex that is a maximum, because that's the highest the graph is, and that maximum is at negative 3, negative 2. Increasing intervals. Okay, so imagine that you're on a roller coaster, up, 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 up. Okay, so increasing is from over here to here. It stops increasing right here, but what we care about are those x values. So the x value way out here is going to be negative infinity. Okay, and it stops increasing here at negative 3. So it's increasing from negative infinity, because I'm talking about the x values, to negative 3, and we're going to use parentheses. And then for decreasing, okay, so now this graph is going down. The y values are getting smaller. It's going to keep going down forever. So here, okay, my x value is at negative 3, so that's where it starts decreasing. And it decreases. Remember, I only care about the x value, so if I look over here, this x value way, way, way out here, remember it's going to keep going, is going to be at positive infinity. So negative 3 to positive infinity. Is there any constant intervals? Nope. I'll put none. Remember, constant interval is if the graph is going to go straight across like that. I know we didn't talk about that much, but that's what a constant interval is. If it's just going straight in a horizontal. Okay, we have the x-intercept. So notice that nowhere does it cross the x-intercept, so there's no x-intercept. Y-intercept. The y-intercept is right here. So the y-intercept, we're going to list this as an ordered pair, is at 0, negative 5. Remember that the zeros are the same thing as the x-intercepts. These two are the same. You just write the notation is different. So there are no zeros as well. Asymptotes, okay. I know that I drew this line in here like this. That's my axis of symmetry. It is not an asymptote, so don't confuse those. So there's no asymptotes here. In behavior, as x goes to infinity, so as x goes to infinity way out here, where is my y value? Well, my y value is way down here at negative infinity. And then way out here, imagine this is way out here, okay, where x is negative infinity, y is still way down here, so it's also at negative infinity. Okay? All right, let's look at number 23. Okay, tell if the following statement is true or false. If two quantities have a strong positive linear relationship, then the correlation coefficient may be represented as r equals 0.25. Okay. Okay, for this section, you need to remember what the correlation coefficient is. Okay, so the example we showed you in class were these three examples. So this is a negative correlation. Okay, think about a line going through there. So this is a negative correlation. This right here has no correlation, and then this one has a positive correlation. Okay, but this is on a scale from -1 to +1. And that scale, okay, the closer you get to 0, the closer you are to no correlation. The closer you get to +1, okay, the stronger the positive correlation is. And over here for negative, the closer you get to -1, the stronger the negative correlation is. And correlation coefficient is how close, or the distance, these points are away from a line of best fit. Okay, that's really all you need to know for this class. All right, so let's look at the question again. It says if two quantities have a strong positive linear relationship, strong positive linear relationship, positive and it's strong, so the closer I get to +1, it's strong, then the correlation coefficient can be represented as 0.25. I'm going to say that's false. Okay, yes, this is positive because it's a +1, but 0.25 is going to be like way down here. Okay, so that's not strong. That's not close to +1. So that's what you need to be thinking about when you are answering these true-false questions. Okay, tell if the following statement is true or false. If a positive correlation exists between height and weight, so a positive correlation between height and weight, a person with above average height is expected to have above average weight. Okay, so let's talk about what that would look like. It says positive correlation, okay, which means the taller I am, the more I weigh. So it's going to look like something like this. Okay, the taller I am, the more that I weigh, which means that this will say that the x-axis is height and this is weight. Okay, if I have above average height, so I'm way out here, I'm really tall, then it's expected that what? I have above average weight, which means that this is true. So a good thing for these true-false questions, when they don't give you a picture, sketch out what you think that the graph would look like. I think that that would help with these. All right, last one. If a scatter graph shows very little scatter about a straight line drawn through the plots, it indicates a rather weak correlation. Okay, so that one's worded difficult. Okay, so if a scatter graph, all right, so let's look at the examples, these examples. If a scatter graph shows very little scatter through a straight line, so very little scatter would be these. Okay, these are scattered everywhere, right? This has very little scatter, okay, about the straight line drawn through them, indicates a weak correlation, okay? Well, that's not true, because it has little scatter, then it has strong correlation. When they're scattered about like this, it has little or no correlation, so this would be false. So again, you got to remember what this looks like and think about this. I would even maybe draw this on your test here. Okay, so if it has lots of scatter, there's no correlation. And that's it for this video.